This video is about solving for a value using properties of similar figures and identifying similar triangles using angle similarity, side angle side similarity, and side similarity. So similarity means the same shape, but not necessarily the same size. There are two types of similarity then. We can do a dilation, which makes something bigger. We can also think of that as an enlargement. And we have a reduction, which makes something smaller. So similar polygons then, as we had talked about before, mean that the ratio of the measures of the corresponding sides are equal, and the corresponding angles are congruent. So we are given that triangle COW is similar to triangle PIG. We're going to draw two triangles. So we have COW and PIG. So we know that CO is 18, CW is 22, PI is 27, PG is 33. We want to find IG is 30, and we want to find OW. So what we can do here is we can take two of the corresponding sides that both have numbers. So we can do 18 over 27. We could have also done 22 over 33. And then we have x over 30. Notice when you set up your proportion that sides from the same triangles are in the same part of their fraction. So when we cross multiply here, we get 27x is equal to 540. When we divide by 27, we get x is 20, so OW is equal to 20. In number 2, triangle PQR is similar to triangle STU. We want to solve for x, y, and z. So we have to be careful because these triangles are turned. So we really got to look at the names to help us figure out our variables. So right now we can easily solve for the angles because we know the angles are congruent. So angle S, which has the x, is the first letter of the triangle. It's going to go with the first letter of the other triangle, P. So we have 7x plus 7 is equal to 72. We can subtract 7, 5x equals 65, divide, x is 13. Angle T is going to correspond with angle Q because they are the second letter of each triangle. So 6z plus 14 is equal to 68. We can subtract the 14, 6z is equal to 54, and we divide, z is 9. It also wants us to find the measure of angle U, so while we are at it right now, we know that S is 72 degrees, T is 68 degrees, so we can subtract those from 180 to get angle U is going to be 40 degrees. We also want to find y in the ratio of the sides. So to find y, we look at the sides that we are given. So we are given PR is 45. PR is the first and third letters, so it is going to correspond with the first and third letter of the other triangle, which is going to be SU. So we have 45 over 75 equals. Then we are looking for this side, PQ, which is the second and first letter. So that is going to correspond with the side that's 35. So we have 4y minus 11 over 35. As we cross multiply here, we get 75 times 4y minus 11 equals 45 times 35. 300y minus 825 is equal to 1,575. We can add the 825 to both sides, so 300y is equal to 2,400. When we divide, we get y is 8. Then we lastly want to find our ratio of the sides. So the ratio of the sides we can use the sides from each triangle. So we have 45 over 75. Those are our corresponding sides. All we have to do is reduce this, so our ratio of sides is 3/5. In number 3, we know that triangle DOG is similar to triangle CAT, and we want to solve for x. So looking at this triangle, we see that DO is going to correspond with CA. We have x plus 6 over 2x equals, we have 4x, which is going to correspond with the x plus 5. So as we cross multiply here, we get 8x squared equals x plus 6 times x plus 5. We're going to have to FOIL that out. X squared equals 8x squared equals x squared plus 6 plus 5x plus 6x plus 30. So we're going to move everything to the larger x squared side. So we get 7x squared minus 11x minus 30 equals 0. In order to factor, we're going to have to factor using split the middle. So we want to multiply 7 and negative 30 together to get negative 110 or 210. And we need two numbers that multiply to negative 210 and add to negative 11. So we would have x squared minus 21x plus 10x minus 30 equals 0. So in the first group, our GCF is a 7x. That leaves us with x minus 3. In the second group, our GCF is 10. That leaves us with x minus 3. So this factors as 7x plus 10 times x minus 3 equals 0. In order to get x, we know that 7x plus 10 equals 0. 7x equals negative 10. X equals negative 10 sevenths. And x equals 3. In this case, our negative 10 sevenths wouldn't stay because we would have negative side lengths. In number 4, given that trapezoid MATH is similar to GEOY, we want to find some of our properties here. So first thing we want to do is we want to find the measure of angle M and angle E. So just like in triangles, we know that our corresponding angles are congruent. So M and G are congruent. They are both 54 degrees. So we know that the measure of angle M is 54 degrees. In order to find the measure of angle E, we know in a trapezoid that we have two parallel sides. So we know that E and G have to be supplementary angles. So we can get measure of angle E by subtracting from 180. So 180 minus 54 gets us 126 degrees. Then we want to find MA, EO, and GY. So I'm going to call those X, Y, and Z. And we can use our corresponding sides. So in order to solve for X, we have X over 2 equals, the only side that both has numbers right now is 12 and 9. So we're going to set that equal to 12 over 9. As we cross multiply here, we get 9x equals 24. When we divide by 9, x is 8/3. In order to solve for y, we have the sides 8 and y that correspond. So 8 over y is equal, again, to 12 over 9. As we cross multiply here, we get 12y equals 72. When we divide, y is 6. Lastly, we have 20 and z that correspond. So 20 over z equals 12 over 9. As we cross multiply then, we get 12z is equal to 180. When we divide by 12, z is 15. We also want to find the ratio of the sides, the perimeter, and the area. So the ratio of sides, we know that two sides that correspond are 12/9. That reduces to 4/3. Remember that the ratio of our perimeters is the same as the ratio of the sides, so that's also 4/3. And then to get the ratio of the areas, we are going to square 4/3. So 4 squared is 16, 3 squared is 9, so our ratio of areas is 16/9. Now, focusing on triangle similarity. There are three methods of triangle similarity. So the first method is angle-angle similarity. If two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. So we see A is congruent to D and B is congruent to F. We know that a triangle ABC is similar to triangle EDEF by angle-angle similarity. In side-side-side similarity, we need three sets of sides of a triangle are proportional to three corresponding sides of another triangle. So if we look at the shortest sides, 3/6, that reduces to 1/2. The middle length sides, 4/8, reduces to 1/2. And our largest sides, 6/12 equals 1/2. Because they all reduce to the same ratio, that means these triangles are similar again. So triangle ABC is similar to DEF by side-side-side similarity. In our last method of similarity, we have side-angle side. So in side-angle side, we know that 3/9, the smaller sides reduce to 1/3. 4/12 also reduces to 1/3, so that's two sets of sides that are proportional, and we have their included angle congruent. So triangle ABC is similar to triangle DEF by side angle side similarity. So explain why these following triangles are similar, and then write a similarity statement. So if we look at the two triangles here, we have QRS and we have PRT. Notice that both triangles right now have a right angle that is congruent. They also share angle R, which makes angle R congruent. So we now have two sets of angles congruent. So we would say, yes, these are similar by angle-angle similarity. Triangle QRS is similar to triangle PRT. In number 6, we have parallel lines. So we can use alternate interior angles to get L is congruent to J. In a bow tie problem, we also know that our vertical angles are congruent. So again, we have two sets of congruent angles. So we would say that these triangles are similar by angle-angle. Triangle HIL is similar to triangle KIJ. So in number 7 in the bow tie problem, we know that our vertical angles are congruent. We also see that we have two sets of sides. So when we look at the ratios, if we have 12/10, the two smaller sides together, that reduces to 6/5. We also have 18/15, which also reduces to 6/5. So we have two sets of sides that reduce the same ratio. We also have the included angles. So we would say, yes, these are similar by side angle side similarity. So triangle MNQ is similar to triangle PNO. In number 8, we have no shared angles, but we have three sets of sides. So we're going to check the ratio of all of them by pairing up the sides that go in order. So we would have the smallest together, 4/8, which reduces to 1/2. The medium lengths, 5/10, which reduces to 1/2. And the longest sides, 6/12, which reduces to 1/2. So because they all reduce to the same part, we know that they are similar by side-side-side similarity. Triangle JLK is similar to triangle VTU. In number 9, we have two triangles here. So we have triangle SNW, and we have triangle, the bigger triangle on the outside. We see that these angles, SNW and NOS, are congruent. We also know that they have a shared angle S, which means that they have two sets of congruent angles, so they are similar. So they are similar by angle-angle similarity. Triangle SNW is similar to triangle SON. In number 11, we have two triangles with parallel lines, so we can use corresponding angles to get one set of angles congruent. We also know that angle A is congruent to itself because it's in both triangles. So again, these triangles are similar by angle-angle similarity. Triangle LAK is similar to triangle FAE. In number 11, we want to solve for X and Y. So we know that these triangles are similar. And we have a smaller triangle inside our larger triangle. So if I am solving for X, we see that X is on the bases of the triangle. So we would have X minus 5 over 52. The side on the left of the triangle has numbers. So in the smaller yellow triangle, the side length is 24. In the bigger triangle, we need to add the two together to get the side length is 39. And then we can cross multiply to solve for X. So we have 39 times X minus 5 equals 24 times 52. 39X minus 195 is equal to 1,248. We can add 195 to both sides. 39X is equal to 1,443. When we divide, we get X is 37. When we go back to look for Y, we still want to use the ratio of 24 over 39 because we know the side lengths. Then with Y, the smaller triangle has a length of 10, and the bigger length, we would add these two sides together. So we would have 10 plus Y. So we get 24 times 10 plus Y is equal to 390. 240 plus 24Y is equal to 390. When we subtract 240, 24Y is equal to 150. When we divide, Y is 6.25. Or if we write that as a fraction, we would have 25 over 4. In number 12, this is the same idea. We have a smaller triangle within a larger triangle. And we want to solve for X and Y. So this time, the X is on the outside of the triangle on both sides. So when we go to set up our ratio, on the top side, we would have 15 from the smaller triangle, and then when we add these two sides together, we would get X plus 17. On the lower triangle, we have X plus 10 on top, and when we add those two sides together, we get X plus 26. So as we cross multiply here, X plus 10 times X plus 17 equals 15 times X plus 26. We get X squared plus 10X plus 17X plus 170 equals 15X plus 390. So we need to get everything to the X squared side so that we can factor. So we have X squared plus 12X minus 220 equals 0. So two numbers that multiply to negative 220 and add to 12 would be X plus 22 and X minus 10. When we switch our signs, X is negative 22 and X is positive 10. So we are not going to include the negative 22 because that would give us a negative side length. So in order to solve for Y, I do have to substitute the 10 into one of the sides. So I'm going to do the top side. 10 plus 17 gives us 27. So when I go to set up my proportion here, I would have 15 over 27 equals our side length here of 10 over Y plus 9. So as we cross multiply, 15 times y plus 9 equals 27 times 10. 15y plus 135 equals 270. We can subtract 135. 15y equals 135. Divide, and y is 9.